Okay, I returned to the Englewood Library grounds in New Jersey, and the Englewood Library has been one of my favorite libraries since in the 19 about 89. Since 1989, I've been visiting this Englewood Library. It has been my favorite library because of the design and because of the relative closeness to my residential apartment then at 2205 in Central Avenue, Fort Lee, New Jersey. Just a little bus ride away, I found it. And if you come, you'll see it as a particular design, the library itself shape. But I'm here on the grounds in my, or rather, this cargo van enterprise, applying my amazing 5x12 matrix. And to continue, let's get a derivative of our 5x12, or 3x3 here, which is a derivative of the 5x12. And let's have it in a general form. Okay, so here I have a 3x3. I have them in pairs, A, B, C, D, E, F. And specifically now, this is a general form and sort of algebraic form. Let's design a 3x3 mesh. And here we have and this is a 3x3 complex. This is 4 ohms minus J2 3 ohms. And now see we have some inductance. Let's give it the complex value, J4 ohms, 2, 4 ohms, and 10 at an angle 0. And you have I1 going in the clockwise sense. And we assume I2 now was going in the counterclockwise sense. And I3, this is the capacitance here. Going in the I1 going in the clockwise, I2 counterclockwise, and I3 going in the counterclockwise sense. We know that if we, after we get the solutions, if the current turns out to be negative, then we just reverse the polarity. And so this was now 30 degrees. This was 2 ohms, J4, and this was 10, 0, I1. So I have all the parameters in. Well, this is minus J6. That's a capacitance, so that would be in farads. Inductance would be in Henry. And so here we have our mesh equation now. If we put in there, we have 10 minus J2 here, 0, 4 minus J2, 0, 6 minus J6, minus 3, 4 minus J2, and 4 plus J2. And then we have the currents now, I1, I2, and I3. And that's now equal now to 10, 6 at an angle 30, and 0. So as usual as we find delta rather, that's equal now to 10 plus J0, 52 minus J2 minus 3 and 9 plus J2. And if we do a mesh analysis and calculation, what we get now is at an angle minus 35.67 degrees. So this now we find out that I1 so the numerator over delta, that's equal to over delta 10 this is basically repeating the same thing there. If we do the calculation here once more, we have an angle of minus 40. And that will be over now 627 at an angle noting that to divide the angles we just subtract and to multiply we had, but we have to keep the angles in radians. Okay, degree in radians. Okay, so that's what we have here with our 3x3 circuit analysis, and that's for I1. Now I2, similarly, we put I2, and we're not going to write out this long matrix, but you'll have to get the format of the by looking at the 3x3 mesh up here. And what you'll get now, that's equal to now that delta remain the same, 627.7. And at an angle and so that's equal now to at an angle this would be for I3. Now I2 similarly equal to
that's equal to an angle.
So you have I1, I2, and I3. So this is now for 3 by 3 mesh, and this is a sort of a general format after we plug in uh, or dimension or parameters from the 3 by 3 circuit here. And this is the actual complex values because we have some inductance and capacitance in the circuit. This is not anything new, rather. We have done these applications before. What is new here is that we have been applying it to a different space. Here we are at the Englewood branch in van space, auto van space, and we are applying our amazing 5 by 12 matrix here in Englewood, New Jersey. All right, we'll take a break and then we'll come back to some magnetization properties of our amazing 5 by 12 matrix.